So yeah, general thing to know if you're playing around with pointers and you want to be able to look at values of them in code. You can usually print them as an integer. If you're on a 64-bit machine, you'd need to print them as a long int or you'll just get the low 4 bytes. But %p is the format that's officially sanctioned to use to when you want to print out a pointer. And it'll give you the right number of digits, and it'll be in hex. And that's just a nice go-to. So you can say right, where pointer's like a struct node star. That should always work well. So ODP questions? So there's code that'll do that insertion, and it's kind of what we described yesterday. Malloc a new node, which I'm calling temp. Set its data field equal to the number. You can do that right up front. And then to adjust the pointers, there's different ways to do this, but the way I'm doing it here, temp next equals pointer next, and pointer next equals temp. Okay, you can do this with multiple variables and sort of piece them together, but let's see what this is actually doing. So here's your node PTR. And here's your new node, which we called temp, and it's got some number that you've loaded in the data field. And we want to sandwich it in between the second and third nodes. So one way to do this is, set second equal to pointer next, set third equal to second next, and then you can just set second next to be temp and temp next to be third, and that'll squeeze it in. But if this is PTR, this is really where PTR next is pointing, right? So PTR next is basically this node, and the next field of that is this node. So this is synonymous with that third node, and so if we want temp to point to that, we can say temp next equals this thing that points to the third node, the address of the third node, and then pointer next, which is where the second node is pointing. You change that to point to temp. And again, you don't have to do it like that. You can set up, nodes named first, second, and third and piece them together. But over time, it becomes more and more convenient to use this kind of pointer arrow next, arrow data, arrow such and such, right, to string these things together. And you can think of it, the term pointer is apropos because, pointer is pointing to something, right? The next field is pointing to something, that's this. The next field of that is pointing to something, it's this. And you can kind of think of these arrows as, dereferencing down a chain of links. And once you figure that out a few times, right, it's a big convenience. And this is also why, remember, we can say something like star PTR dot next, and that's a synonym for PTR arrow next. But if we wanted to do this kind of statement using this notation, well, this first field is star PTR dot next. And then if we want to see what that points to and pick off the next field, we have to dereference that. and then put the next field on there. And they may both be confusing, but this is going to make sense a lot more quickly than that is, right? And if you're trying to do 3 or 4 of these, this becomes a big chain of nested parentheses with lots of stars in front. And if you're going to do something weird that breaks the pattern, you're almost never going to succeed in figuring it out from this. Here it's going to be pretty straightforward. So that's really where this usefulness of this synonymous structure really comes in, is when you're chaining these things together. When we get to trees, this will come in full force, because some of the algorithms we'll be doing will want to say, take this thing's left child and look at its parent and look at that one's parent and then look at that one's right child. And it can all just be one expression, just arrow left, arrow parent, arrow right. So we'll see that later. So whatever form you want to put it in anyway, that will do the insertion between the old second and third nodes after creating a new node. So we're on a break from ODPs until Monday, and Monday I'll start posting ODPs for our next programming assignment, which will be related to hash tables, which we'll start talking about by Friday, possibly before.
When will you post it?
Probably pretty close to Friday, because I gotta write it. And then we just take another quick run through the GDB quiz, and I'm gonna do something different. So we started looking at this yesterday, right? So start the debugger on this file temp G1 on the server, put a watch point on I, step through till I is 5, print the value of X at that point. How many bytes are allocated for struct? We said we could just use size of in a print statement. Print the address of the variable data. You can just print ampersand data. And once you do that, you can start looking at the structure a little bit. What's the address of data bracket 0? Well, again, you can just print ampersand data bracket 0, right? And that should tell you where it's stored. And then print the address of data bracket 1 and data bracket 9. And while you're doing this, what you're going to be working on is building a little memory map. For this section of memory where this variable data is stored, how is it organized? Where is element 0 of this array stored? And what's stored in the first location there? What's in the next location? What's in the next location? And so data is an object of type myStruct. There's a typo in there. And it contains a number of fields. And so try to figure out how those fields are organized. And you can do this by printing the address of, data bracket 0.x, data bracket 0.y, and see if you can figure out how this is organized. And it's not packed in, right? Where one variable ends, the next variable does not necessarily begin in the next location. There's padding put in there sometimes. Because, for example, we like integers to start on addresses that are multiples of 4. We want long integers to start on things that are multiples of 8. We want pointers to start on multiples of 8, and so on. So you're going to play around with GDB. You're going to take apart this structure and try to figure out what it looks like and make a map. So work through those, right? This is due on the 5th, I think. We'll play around with it sooner rather than later, and ask questions. Yeah.
For PA2, do we have to have like 100 different notes, or it's just 200?
PA2, you should be able to put in as many nodes as you have memory for in your machine, which will be like probably millions. Because you're malloc-ing, yeah. So there's no arrays of struct nodes in PA2.
Yeah, I was thinking of a way of going through the different nodes, seeing how much we don't.
Yeah, no, you never have to do that. And there's no place to do that, actually. All right, any other questions? All right, so I've never done this before, but I'm going to do a PowerPoint presentation in CSE 222. It's never happened before. It may never happen again, except an hour from now. But this is amazing. So, but I need to talk about some things. I need to talk about plagiarism and cheating, because there were a number of incidents on PA1. And there's usually, during the course of the CS sequence, there's 1 or 2 times that something comes up. But, you know, it was several times on PA1, and that's the first assignment. So we need to talk about this. And I don't know if this ever really gets talked about. I mean, on the syllabi, you see, you know, code of student conduct, and it's like, don't cheat, you know. But I don't know if it really is ever discussed what that constitutes and what it means. So I want to just have a discussion about that. So plagiarism and cheating, right? So this is cheating, except they haven't actually brought anything up on their browser there. But presumably they're going to, right? And plagiarism and cheating are different things. And I've seen both going on in this course already. And I'm more concerned about plagiarism, because plagiarism is often unintentional. Cheating, I'm not worried about, because that has its own mechanism for dealing with it. But we'll talk about that a little anyway. But let me start off by saying accusations are really powerful things. They're really dangerous things. Sometimes they're appropriate. But I'm very, very hesitant to accuse somebody of cheating. Okay, even if I have very strong evidence. And the reality is most students are working on their own. They're trying to do their own work. They're trying to learn. And if a line gets crossed, it's a line that we call plagiarism. Cheating is much more severe. So here's a famous quote. I look at this code and I look at you and I just don't see the connection. Right? What a horrible thing a teacher could tell a student. Basically, you don't look smart enough to write good code, right? And I was the unfortunate recipient of these comments when I was an undergrad. So that was me on the left, and the teacher making the accusation. He worked for the government. He was a part-time teacher at the school, and I guess in his circle, programmers didn't look like this, right? They probably wore suits and ties and had short hair. And it was an assignment that was pretty difficult. It was the first one of the quarter, and I was the only person who got it done on time. So he actually gave the whole class a 1-week extension. But I turned mine in anyway. When I got it back, instead of a grade, that was what was written on the top of it. And he didn't talk to anybody in the department. He didn't talk to the other teachers who knew me. He just looked at me and said, yeah, you must have cheated. And in my case, what saved me was there was one piece of the code I couldn't get to work. And so I had modified it. It was supposed to run a cross-reference on its own code. And so I modified another part of the code that was breaking my algorithm so that when I tried to cross-reference it, that error wouldn't show up, you know. And I explained that to him, and everything worked out in the end anyway. But accusations are powerful things, right? So I'm very hesitant to accuse people of you know, deliberately trying to cheat. So what is plagiarism, right? Plagiarism is basically copying somebody else's work. And it can be a tricky thing to clearly identify, right? Particularly since, you know, we're not inventing new programs here. We're writing things that have been developed for, you know, decades. Algorithms that were developed in the 50s. We've got textbooks that I give you to use that have code in them and have algorithms in them. I give you code and I show it to you during class. every C program ever written probably has integer main parentheses int argc comma char star star argv close paren curly bracket, right? So you can't just say, yeah, this looks like that because it's got the same integer I in it, you know. They both say I equals I plus 1, you must be plagiarizing. So in written work, there's this thing called the 5 consecutive word test. And it says if 5 words of what you've written are the same as 5 consecutive words in another paper, that can be considered plagiarism. 5 words. That is not a lot. Right? Don't put that in your paper, you're plagiarizing me. So it's a loose rule of thumb, right? And if it's a generic phrase, like, you know, that is not a lot, then it's not going to constitute. But if you're writing a technical paper, and you have 5 technical words in succession that are the same as from another paper that you didn't cite as a source, you can be brought up on plagiarism charges. And I know at least one case where this was used inappropriately by a teacher who had a vendetta against a student and was grading their paper and scoured the literature and found a paper with the same part of a sentence in it and brought the student up on charges. And they were exonerated in the end, but it was a nightmare while it was going on. So plagiarism in you know, written text is tricky, but it's a similar but bigger problem in some ways in code because, you know, for I equals 0, I less than 10, I plus plus. Has anybody in here ever written that statement in C before? Right? Can we say that's plagiarism because, you know, somebody 10 years ago wrote that in their program? So it's hard to nail down what exactly plagiarism is. But it can be done. And the other form of plagiarism that you hear about in English writing, for example, is even if you use different words, right? You have a paragraph that's presenting an argument. So here's this fact, and here's how the two relate, and here's what we can conclude. And you can write totally different words, but still present that same first fact, the second fact, the same way that they relate in the same conclusion, and that can be considered plagiarism. And it's kind of like copying pseudocode, right? Different implementation, different variable names, different structure, but same set of steps. And that's hard because I give you pseudocode for algorithms, and most teachers do, right? Especially when you're trying to learn an algorithm, we're not asking you to invent a linked list. We're asking you to use these pre-developed concepts and write some code to implement them. So helping friends is good, right? I keep telling people you're encouraged to work together. I'm fine with that. I want you to work in groups. But there's a line you have to watch out for. And knowing where that line is can be tricky. And that's part of my goal here is to let you know that there is a line and to help you figure out that you know, you have to stay pretty clearly on one side of it. So pretty safe talking about algorithms, talking about definitions, concepts. What is a linked list? How do we insert? Why do we need 2 pointers to go through a linked list? And as we keep developing data structures, these concepts and algorithms become more and more complex. When we talk about red-black trees, it's going to be, you know, 5 whiteboards filled with examples of how we do certain things on these structures. So those are almost always safe to talk about. That's basically what I'm trying to help you with in this course. So talking about those is safe and encouraged, right? Because you can help each other understand things in more ways than I can, because I get one shot at it. Proceed with caution around pseudocode, right? Now, if it's pseudocode that I've given you, or that you're trying to understand from lecture, that's pretty safe. But if you're trying to figure out how to do something that I haven't given you pseudocode for, that's not in your textbook, and you come up with a really clever algorithm, and somebody else has exactly the same clever algorithm, that can start to be a gray area. It kind of depends if your goal is to write the C code or to come up with the algorithm. If a teacher says, I want you to figure out how to do such and such, and 2 students figure it out exactly the same way, that can be as bad as having exactly the same C code. Right? So that kind of depends on context. In this course, pseudocode's probably safe. Definitely on the other side of the line, actual code. Okay, if you're looking at actual code or letting somebody else see your actual code, that's a danger area. okay, and there's a chance it's going to burn you. So I've seen reference to various ways to deal with this, but basically it's very hard to unsee something once you see it, right? So imagine you're trying to get your node deletion to work in a linked list, and you can't figure out how to nail it down. You either miss the first node or you get a seg fault at the end or something like that, and you ask your friend and they show you their code, and it's like, oh, that's brilliant, that makes perfect sense, right? Well, you can go over to your own terminal and start writing on your own. You've seen a solution, your brain has seen a solution. Our brains are not wired to say, I know how to solve this, but I'm not going to do it that way. I'm going to come up with a new way to do it, right? You're probably going to write to a large degree the code you just saw, and it's just really hard to avoid. So I've seen reference to the Gilligan's Island technique, right? Somebody said once you've seen somebody else's code, go watch 3 hours of Gilligan's Island reruns, and that will purge your brain of anything useful, and then you can sit down and write code cleanly. But I don't recommend that, even though I like the show. Right, it's better just not to look at anybody else's code, and definitely don't let somebody else see your code. And here's the danger, right? And I've already mentioned this to some degree. At most universities, I don't do this, but at most universities, you submit your code electronically. One of the first things that happens is it gets run through a system that basically looks for plagiarism. It basically takes pairs of submissions and does analysis on them. And this code has gotten pretty sophisticated. So changing variable names, indenting differently, spacing differently, moving things around inside a loop is not going to trip these things up, right? They're designed to factor that out, put it into a form that basically captures the essence of the code and says to see, are these the same submission or not? And in a lot of cases, if this code kicks out 2 assignments and says these are the same, you get a 0, right? It goes right into the grade book, and nobody looks at it beyond that. And that's best case, right? You got a 0, and you can go talk to the teacher and say, you know, this is what I did. Worst case, you get an F in the course, and possibly you end up being sent to the honor board. Okay, first offense. Okay, so what does it mean when you get sent to the honor board? This is what happened to my friend who was accused it wasn't a coding course. But got sent to the honor board. So what's that mean? It means suddenly you're trying to document your work. Hopefully you've been pushing copies of your code to Git as you develop it so that you can create this paper trail saying, you know, I worked on this solidly for 2 weeks and here's how my progress changed and how my code changed and so on and so forth. You're trying to get character witnesses, you're talking to old teachers, asking them to write you letters of reference, saying this person was a good student, they worked really hard. You're basically trying to build a case to defend yourself, to show that this was your own work, and that whoever turned in your copy of the code, you didn't knowingly help them. You didn't know they were going to do this, you weren't trying to help them cheat, right? And this is happening while you're still taking your other courses and you're keeping up with all your coursework and homework and so on. You may have been kicked out of the course that you were accused in, and so you don't have access to the lectures, you can't come to the class, you don't have access to the assignments, so you're trying to keep up with all of that, and you've got this cloud hanging over your head of something that can seriously alter your life path, right? It's not a good time. And in the best case, you're exonerated in the end, but you're already out of the course, so you're going to have to take it again the following year, and anything that depends on that course gets pushed back a year. And now you're looking at another year of paying money out and getting deeper in debt instead of working at a job and making money and getting on with your career. All right, worst case, you're expelled from school. And this can happen, and this can happen on a first offense. And you're out of school, you don't have your degree, you're no longer on a path to a degree, and every time you try to go to an interview for a job or admission to another school or something like that, the conversation is going to degenerate into a discussion about why you were kicked out of this program in this school. And it's going to follow you around, right? And it may be through no deliberate misdeed on your part, right? Somebody was stuck on this code and they've helped you in the past, and so you said, yeah, here's my solution, don't copy it though, and they copied it. So this is serious. So what do? Do something different, okay? Because like I say, for the most part, I know people in here are trying to learn these concepts. They're turning in their own work. They're trying to, you know, write the code themselves. But there's too much movement on the wrong side of that line. So some suggestions, right? Work with others on concepts, algorithms, pseudocode, write the code alone, okay? Don't let anybody see your code, don't let them see your printouts, don't let them see your screen, right? Now if you know somebody really well and you trust them, that's okay. But you know, you're writing code on your laptop and you gotta go off and get a drink of water or something, lock your screen. Because somebody you don't know very well, who knows that you're a good student, might come by and just take a look at what you've been editing. It sounds a little crazy, and I don't want to make people paranoid, and I don't want to say we have to live in this totally defensive mindset, but basic things, right? Treat it like you would a credit card number. If you were going to walk away, would you leave your credit card sitting on the desk? If somebody said, hey, can I take a picture of your credit card? Would you say, yeah, sure, go ahead. Just don't use it, right? Don't ever send your code to anybody except for me or yourself. Okay, this includes Discord. Once you send a screenshot of your code or lines of your code, right, you can't take it back. Keep your Git repositories private. Keep me as a reporter, though. If it's a group project and you're working with someone, give them, you know, reporter access or, you know, access so they can make changes if you want. But don't just take a public repository and push your code out there, right? And then, you know, use Git. It gives you a track record. We've talked about all the good reasons for using Git, right? Well, here's another one, right? If something comes up, you can go back and you can show, you know, how you developed your program over the course of a week or 2 weeks and the missteps and the changes and how you work to a solution. Whereas somebody who deliberately cheats will have nothing to show, and then all of a sudden one day they've got the code and it's done, right? Doesn't mean that if that's what your situation is that you cheated, okay? But if you have a nice, clear, documented track record of developing your way to the final thing that you turned in, that argues strongly against the idea that you just got the code from someone and cheated, right? Make sure you understand your code and the algorithms and such. Document your code, right? Comment it. When you figure something out, put a little paragraph in there explaining what you figured out. It's useful for you down the road, it's useful for somebody else reading the code, and if some question comes up later, right, it documents your development process. And you can always just like ask if you've got questions, right? Hey, I looked at this person's code by mistake, and now I'm worried that I'm cheating, and I'm gonna get kicked out of school, right? And let me know, you know, and I'll look at your code and, you know, you can tell me your understanding of it and stuff, and we're okay. And it's something to just figure out, but figure it out now before you transfer, right? Because a crackdown is coming. I'm predicting in the next 2 to 5 years where you're gonna see a major change in methodology for computer science education, and it's going to include a lot of things that deal with all of this, and you don't want to get caught up in that inadvertently. All right, so most students are trying to learn and do on their own, and that's what that part of the talk is about, is basically the people who are doing good work, taking the course seriously, and I'm just worried about sort of, you know, slipping on the other side of that line. But I want to talk about the other case, which is cheating, because it does have an impact on us. And I'm not worried about that in most cases in my classes at Clark. It's pretty unusual. But I want to say a few things about it. So a lot of this comes from, you know, places like Chegg, right? So-called educational sites where you can post questions and experts will help you understand what you're confused about, right? But in reality, they're primarily used as cheat sites. You post your physics homework and somebody will sell you the solutions to it for a few bucks, right? And this is a well understood phenomenon. It's a big business, a lot of money involved, and it's starting to be cracked down on, right? So a number of states, including Washington and Oregon, now have legislation criminalizing things like selling papers, selling dissertations, posting academic work for sale, things like that. But, you know, it's a hard target to nail down. But these things are out there. So what can you find on a site like Chegg? In this assignment, you're going to implement a linked list using an array of structures as described in class. The problem has been solved. See the answer. You click on that, give them 14 bucks, and there's a solution to this homework assignment, right? And the poster said, you know, please write this in C. I appreciate all your work. Somebody else also had a similar idea, and please help me out. I appreciate your work. Thank you. So people are very polite about this, right? But you know, this is PA1. Guess what's not going to be assignment 3 in this course? Yeah, this was last year's PA3. Stacks and queues, and the solution for that is readily available. There's CSE 215. Guess what falls 215 programming assignment 1 was? Write a code to deal with sets. Well, click on that, you got the answer. Now, most people won't do that, but some people may be tempted to say, you know, I'm really stuck, I'm not going to copy this, but I need some help. I just want to see pieces of the working solution, and then I'll figure it out on my own. And then you're back to this question of how do you unsee what you've seen, right? And that's where you end up inadvertently writing code that's actually coming from your recollection, your memory, instead of from your own understanding of programming. And there's an ODP 210. Problem has been solved. So this is sub 24-hour turnaround, right? There's lots of experts out there eager to help students in their studies. And this is so ridiculous, right? I mean, these ODPs are for students to learn concepts and test their understanding, and they're a fraction of a % of your final grade. And some students would rather, you know, upload these to Chegg, or maybe to Essay Taste, a different but similar site, or maybe to Academic Works Help, a third site, or maybe to Course Deep, a fourth site. Right? It's big business. And what does it cost you? Well, this one, $5.90 to view the answer to ODP 410. Chegg is a monthly fee. It's more economical, right? So this is an issue, right? There's some problems with this, right? First of all, code's very easy to identify. Coders leave fingerprints, right? And if you're a very good coder, you know what these fingerprints look like, and maybe you can take a piece of code and erase those fingerprints and replace them with fingerprints that aren't yours either, and have a piece of code that can't be tracked back to the original. But that's hard to do, right? So, so I've done things like, for PA1, right, I had 2 examples of cheating there, and so I was able to pull down the code and run it back through people's submissions and found out who had done this. And in both cases, those students had already gotten either a D or an F on the assignment because it wasn't written to spec. Why? Because the person who wrote it wasn't listening to the lectures. They were off somewhere else, you know, working for Chegg. And so they'd already gotten a D or an F because I said you have to do things like this, and they did it some other way and so on, right? So the student's being suckered, and they're not getting a really good grade anyway, and they're not learning the concepts. So that's a lose-lose. And, you know, you cheat your way through Clark, and you get into a university, and you cheat your way through that, and you get an internship, and you get people to write your code there, and you get a job, and you get friends to write your code. Unless you're going to spend your life outsourcing your programming work to other people, this can't be sustained, right? And I mean, it makes no sense. So the biggest problem with this is something like imposter syndrome, right? Imposter syndrome is this mistaken belief that you know so much less than other people, right? And everybody suffers from this. When I was a graduate student at Duke in math, everybody thought they were the mistake. Everybody had this fear and belief that they somehow slipped through the admission process, weren't qualified to be there, but somehow they got into school anyway, right? And we all felt that way. So I'm almost 60, I've got patents, I've got publications, I've got 2 businesses, I've got a PhD. I still suffer from this sometimes, right? I submit a paper that I don't feel really good about, and it gets accepted, and I think, well, I wonder if they just accepted that because they recognize my name, and maybe there's really nothing in this paper, right? It's a really easy mode to fall into. And the reality is more like this, right? You see someone out here and they know all the stuff, and you know this tiny little bit of what they know, and you think, oh, they're so much smarter than me. But the reality is, we all know different things. And so the overlap with each person might be small, but it's really not this situation over here where everybody else is so much smarter than me and I'm shouldn't be here. But with people cheating and turning in code that works perfectly and doing it, in 2 days, it feeds into this syndrome. And, you talk to these people and it's like, did you really finish that program? And they'll say, yeah, it was easy, I mean, he gave us the pseudocode, there's really nothing to do. But you ask them how they did it and they can't tell you why, because they don't know, because they didn't actually write it. You ask them to explain, well, how do you delete from a linked list? And they'll either like evade you or they'll give you an answer that makes no sense because they don't know how to do it, which is why they were cheating, right? But all of that feeds into this idea of, I'm in the wrong place. Everybody else here is so far along and I really don't know what to do. And that's a really self-defeating cycle. Because what happens, you stop asking questions because everybody else seems to get it, and you stop talking to the other people in the class because they all seem to get it and you don't want to look like you're not as smart in front of them. And eventually you stop coming to class because it's such a downer being in here, watching everybody else who's so smart and gets this stuff so quickly and you're struggling. And so you say, well, I'm just going to go home, I'm just going to work on this on my own and go through my notes and watch the lectures and figure it out. And Monday comes and that hasn't happened, and so you don't come to class again. And it's just this vicious cycle. And it's really fed into largely by people who are, buying the code for $5.90. And that's a big problem. And on the teacher's side, right, a teacher looks at this and they're like, well, I guess it was a fair assignment because, 5 students did it perfectly in 2 days. So I'm not going to worry about these ones who got an F because they didn't turn in working code, And I guess we spent enough time covering linked list because people are getting it in their code, so we're going to move on to something else and we can pick up speed, and I can put these hard programming questions on the exam because people get it, obviously, and the course becomes more and more out of balance with reality. And the people cheating aren't learning anything, right, because they're buying solutions. The people who aren't cheating and are trying aren't learning anything because the class has gone totally wacko and is going at this ridiculous pace, and you're not covering things that need to be covered, and nobody's learning anything. And it's just a waste of time, and it's lost opportunity, and it hurts the students. Right? So this is part of why I think changes are coming in the next 2 to 5 years, because this is getting to be systemic, and it's well understood, but we need to figure out what to do about it. And there's practical problems with all of this, right? I love automated bill payment. Computer programmers are the best, right? And you get this kind of stuff happening. This self-driving car sure is great, but the people who wrote the code learned a lot in school. This automated assistant sure is great. Hey, personal assistant, play some music for me. All right, so people who are coming out with programming degrees, they're the people that are programming our world, right? Our medical systems, police records, education records. What did you get in school? What's your car going to do now? Are you going to be able to get into your house? All of this stuff is being written by people who, to a large degree, aren't able to write code. And that's a problem. And it's getting worse, so it's got to change. So what's the solution? I'm going to say watch out for the landmines, right? Try to stay away from the things that can potentially get you in trouble. And don't get caught up in where other people are or where they seem to be, right? Do your thing. Find colleagues that you can work with, right? People who support you and who you can support and who are at a level that works for you, and work together to figure out the underlying stuff, and then write your own code and just do your own thing. You'll get there. I definitely sympathize with the idea of it being hard. Okay, for me, physics was like horrible. No matter how much I spent working on homework, going to class, going to the TA, thinking about it, struggling with it, I just for the longest time. Could not get it. F equals ma. It's really simple. It's one equation. What's the problem? Couldn't figure out where f was, where m was, where a was, where the arrows go, when you throw in a cosine or a sine, right? Really, really frustrating. And coding is that way for a lot of people in this course, right? That's natural. It's trying to learn how to think differently so that you can express your algorithms in a way that can be turned into C. But you'll get there, right? Just follow your path and ask for help, right? I'm not going to laugh at somebody because they aren't quite sure how a while loop works, you know. If you've never struggled with the question of how a while loop works, does the while happen at the top or the bottom? You know, if you do an if inside a while loop, does it happen if the while failed? I mean, whatever, right? Come and talk to me, and let's work out the details, and keep following whatever path you're on, and you'll get there, right? And then you don't have to worry about this stuff anymore. All right, so that's kind of all I had to say on the subject. I don't know if there's any questions or comments.
You made it sound like you think programmers are getting worse over time because of some of these issues, like in the industry.
Well, it's not just me, but that's generally the impression.
Really?
Yeah, if you talk to recruiters or hiring departments, the general consensus is like, 98% of people that come in with degrees don't know how to program. This is why FizzBuzz is a thing, right? So if you took 224, there was a question on the final for FizzBuzz. It's a children's game. You write the numbers from 1 to 100, but if the number is divisible by 3, say fizz instead of the number. If it's divisible by 5, say buzz instead of the number. If it's divisible by both 3 and 5, say fizz buzz. And so writing a C program to print 1 through 100, but 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, and so on. And apparently like 99.5% of programming position candidates can't write fizz buzz during an interview. And yeah, maybe that's anxiety and stuff like that. But should be able to at least make a start on it. And yeah, it's a problem. I don't have personal experience with whether it's getting better or worse, but the consensus seems to be it's not getting better. And I don't know exactly what all the factors are to that, but yeah. Which means if you can write FizzBuzz, you're at the top of the pack to begin with. If you can code a linked list during a job interview, you're in really good shape. And you're going to code a lot of linked lists in this course, so that's good. Yeah?
You talked about what universities do, and I know it says in the syllabus, what do you do?
What do I do?
In these cases.
Well, that's a good question. We're going to find out in the next few weeks, I think. Generally, because this is sort of the first programming sequence for a lot of people, and because that's part of what we're trying to do is figure this stuff out. Generally, the worst I'll do is give somebody a 0, okay, at least for the first time that I catch them. I may give them an opportunity to rewrite the program, particularly if it's a program that we're going to be building on. I may say, take 5 days, write this yourself, and I'll grade it. But for repeat offenses, right, I'm definitely going to start giving out 0s, and I might start giving out Fs. But I like to think it's not going to come up. But that's part of my reason for doing this, right? And again, cheating, plagiarism, kind of two different things. Certainly if I discover cases of cheating, that's much harsher. And that will be at least a 0, but it could be an F. Probably not going to send people to the honor board, but if I give you an F, and if you don't learn how to program, you're not going to pass the course, and that's kind of the same outcome as the honor board. But I don't want to put something on someone's record and have it follow them around. That's not my place, I don't think. So, all right. I will let you out 55 seconds early. Thank you for your attention, and I will see you tomorrow or in 2:15.